Yeah, and there are other parameter for sphere like I show you. Um, okay. TS sphere. Where should I? Yeah, and let's go here. TS sphere. So yeah, mm, you see here, sphere, not here. Why it's mm, yes. So generally, when you define a sphere, you should define maximum radius, minimum radius, d phi, and uh, d. Yes, s phi. Yep. Let me show you what it exactly means. I just copied it and we put it here. Okay, and we name it sphere. And yeah, actually, when you are not setting it here in this uh, parameter setting in the parameter setting, so it generally takes the default values what Topaz developers have provided, but maybe you don't know what they have provided, so it's always good to set things by yourself. Okay, so let's see now. Look, seems like there is error. So these parameters are not good. Um, there is like maybe we don't need, we cannot take this thing d phi and s phi. Let's check again. So nope, this d phi and s phi is not the right parameter. Um, Actually, I have used it in my studies to define a sphere. Oh, where is it? Mm, maybe our yeah, Topaz training has it. TS sphere. Yes. So you see, you define d phi, s phi, and then s theta. Okay, we haven't defined these values, so maybe this is the reason. Let's copy this. Mm, eh, okay, now it should not show us any. Yep. You see, we changed it is why it's half sphere. It is because of this 90-degree rotation. D theta, d phi. I show you. 180, and then we close. You see, it's complete sphere. So, and similarly, you can do this like it's actually the spherical coordinate system. It works on d theta, d phi. So you can set it to 180. Another here also, you should get half sphere. You see? So maybe you don't want to use the complete sphere in your simulation. So you can do something like this. So these are the complete parameters for a sphere. Like you have to define your R min. Um, Let me show you the R min as well. And let's set it to 1 millimeter. Okay. And let's see if the box from the middle, the sphere from the middle. You see? And let me zoom in and remove some things. Okay, we just want to see sphere. You see, it is having it's kind of like a shell.
Yes.
It is not a complete sphere.
Complete sphere. Yes.
Yes, so you can control through these parameters what you want to simulate, and then maybe you don't want the complete shell, then you can also define with your phi and theta, you can control it spanning like which part of sphere or shell you want to simulate. Okay.
Okay.
And using these basic geometries, you can actually simulate whatever you
Sorry.
want. Okay. So yes, this so for if you want to simulate a sphere, you have to at least define these parameters like minimum radius, maximum radius, theta, phi, and yeah. Another thing is drawing style. What you want to see. Like right now, you are looking at this kind of like it looks like they are wireform. There's like if you want to see them off there, you have like these options: full
Okay.
wireframe. So this is full wire. Let's try with the our sphere. Yeah, so it's full wireframe is this, and this is solid, you don't see anything inside, and this is cloud.
Okay.
So you can check whichever you want to see. Like for instance, your present graphical user interface doesn't allow you to make interaction like this. I can search for like how you can uh, install your own such interactive user interface, graphical user interface, and I will let you know. Okay.
Okay. All
But
right.
for now, you can like define here itself, like drawing style. You can put cloud.
Cloud. Yes. Cloud. Yeah.
It will show you in the cloud form. You see?
Yes.
So uh, you can directly specify such things in your text file or the input file for Topaz. And
Mm.
another thing is binning. So it has like divided the sphere in three bins around along x, y, and z. Maybe you like, for instance, we will need to calculate absorb those or photon fluence in our box of our simulation setup like we have defined. So it is voxelized or it is divided into x, y, and z bins or boxes. So here also they have like divided sphere into three bins each, and then the sphere was translated from the center in X, Y, and Z direction. That's why we see it in the corner. And like I mentioned, you can also control the color you want to specify for your geometry. Okay,
Yeah.
so now we need to see how is parallel world defined. Do they have any? Nope. You see, this is something. Uh, it is a little advanced with the graphical user interfaces like use Qt. So Qt is uh, a graphical user interface type, and if you use it, maybe, and the OpenGL is also a graphical user interface type. So which graphical user interface you want to use can you can specify here, but now we need to look for parallel world. So you see here is parallel, so you define them parallel by this method. You set it true, and it will be then then you can place things like inside one another. And Topaz generally doesn't recommend you to use this kind of method of parallel geometries, but sometimes you need it, particularly when you want to simulate brachytherapy experiments. So you see our this box, first box in the mass world is not parallel. You see it has type, material, length, drawing style, bins. It has only two bins and its color is blue. But if you see the other boxes like a box in parallel world, it is uh, parallel, and similarly it's true for sphere. It is parallel as well, and that's the reason you see box inside a box and a sphere inside it as well. Okay.
Okay.
So this, I wanted to share this concept with you because we will be using it in our geometry now.
Okay.
Okay, so we are done with this. Now let's focus on our geometry that I have chosen for our workshop here. This workshop, CD Topaz works. Yeah. So these are just output files that ends with dicom, because I chose an output as dicom, so we can remove it. And I'm scoring absorb those and photon fluence. So there we are using two scorers. So we'll check this. So let me remove this. And the output, we don't need it right now. So yeah. So yes, we have our Topaz input file. Then there is this is the Python script that have developed for this workshop, and yeah, and this is separate. I will let you know why I'm using it. It is for the track length estimator. Like okay, let's keep it for future, not today, because it will complicate your understanding for now. Okay, so now we see our input file. So, it is always good to do some commenting like this, like which section is defining what. So, like it sets computational parameters. So it's like seed and thread number, like how many threads of your computer you want to use. So if you want to use the full capacity, you can specify it, and maybe you set to 0. So Topaz will automatically decide how much is available and how much it can use. Okay.
Okay.
And we already went through the material definition, so we'll not go. Today we'll check the geometry definition. So see, we have defined our own world and we made it invisible. We
Yeah.
made it visible because we set invisible to false. Then we have like the base. Okay, let's see here. This is actually um, okay. Let's run it maybe. Bin and topaz. Uh, mm, what's the input file name? It's Topaz Workshop. You see. So I show you the scene. Let's shrink it. So we have this seed that is radioactive cylinder. These are grids, so maybe we don't want to see them. Oh, it's hard to. Actually, the geometry is a bit complex because of the seed and the binning of the grids, and that's why my computer got stuck with this when I tried to change this. make like C or NC some of the components. But yeah, basic I want to tell you is you see the complex geometry is really complex. So I've defined one is the peak box. Let me remove everything. Uh, okay. So these are grids, and maybe we don't want to see it, but if I try to remove it, it will take a lot of time to come up or get removed. So let's start beer it. So you see there is this grid. This grid is actually to store the absorb those or the fluents, and this is our iodine seed. Above the iodine seed, I have defined the lead base. So this is it's a shielding box, and then this is another geometry that is a box filled with air inside which we placed our source. So I called it source placement. And the third is the tumor. This is it is also a box uh, inside which we have this yellow box. Okay. So basically we have four geometries, three boxes parallel to one another and the source. And this grid or the dose scorer is not our geometry. Okay,
Okay.
it is a scorer. So you see here peak. I've defined. It comes from the box, like I said, the base. Then it's another source placement box. It is filled with air, and then is the tumor. It's also a box made up of tumor material that I took from ICRP report, the composition. And I've done the same thing uh, defining what drawing style that we want to see and what color. So I've used it. So basically, it's the same thing like we saw in the parallel world, and these boxes are not actually parallel in the parallel world. That's why I didn't use the parallel world concept here. But when I define the source geometry, you see, here is our source. I will send you this input file. Maybe I will upload it with the in the open OneDrive or somewhere where, and I will leave the link in the comment of the video that I will upload to YouTube. Okay,
Okay.
and then you will be able to check it yourself. So here in the source definition, I have used the concept of parallel world or layered mask geometry world. So there are two things. There is the seed world and the active world. Like one is the outer structure of the seed and another is the activity placement. So we'll check it in more detail together, maybe tomorrow. And here I've used this. I wanted to show you the parallel world. Yes, you see, is parallel is true. So they are in the parallel world geometry. Okay,
Okay.
perfect. So let's meet tomorrow and we discuss the remaining tomorrow and we'll look at the physics as well.
Okay. So I'll also be waiting for the drivers to make the interface.
Uh, the environments to
Yeah.
set the interface. You mean the graphical user interface?
So you rather when we run one
Oh,
box on mine.
seems like I haven't. Uh, this time, do you remember I turned on the video?
You want me to turn on the video?
Okay, seems like there is only one video. I forgot to turn on the video second time.
Oh, okay.
So it's a trouble, but no worries. I will send you the input file and
Okay.
you can use it.
Okay.
And about the graphical user interface, let's not touch it for now. It is bit advanced, so let's keep whatever we can control for now, and then we'll switch to more advanced in future.
Okay.
Okay.
No.
See you then.
Thank you.
Okay, bye.